Today's topic is elastic collision, finding the velocities after collision of first body and second body final velocity. We shall see the common expressions and finally substitute the conditions. Elastic collision. In the last class we learned that the elastic collision means first the linear momentum of the system considered means before the collision, after the collision, the total linear movement of the system remains same, and kinetic energy of the system conserved. These are the two conditions for the elastic collision. Let us consider a simple body of mass m1 moves with initial velocity u1, and other body m2 moves with velocity, both are in the same line. Now what happens? Let us say collision occurred, means like accident occurred. What happens? Assuming that after the collision also bodies are moving in the same straight line. Now the velocity of the first body, which is called v1, final velocity, and the second body velocity v2, right? Now according to the first condition, linear momentum of the system can be conserved. What is the linear momentum of the system before collision? m1 u1 is the first momentum of the first body, plus m2 u2 is the momentum of the second body before collision, and m1 v1 with the first body momentum and second body m2 v2. We can write it as equal. Conserved means before and after are equal. Now you keep it as equation number 1. Similarly, kinetic energy can be conserved. What is the meaning of it? Of m1 u1 square plus of m2 u2 square is equals to of m1 v1 square plus of m2 v2 square. Shall I write of gets cancel taking common, and I'll write common expression f1 u1 square and m2 u2 square is equal to m1 v1 square plus m2 v2 square. You write it as expression number 2 or equation number 2. Now from equation 1 we will write it as, we'll take m1 on one side and m2 other side, m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. m1 taking common, u1 minus v1, and m2 taking common, v2 minus u2. You write it as this is expression number 1 star. Right? Now from 2 we'll write it as m1 taking common, m1 u1 square minus v1 square, m2 is taking common, v2 square minus u2 square. Just Now what is this? You can write it as equation number 2 star. 1 divided by 1 star divided by 2 star. Right. M1 U1 minus V1 by M1 U1 square minus V1 square. M2 V2 minus U2 by M2 V2 square minus U2 square. So now M1, M1, M2, M2 gets cancelled. U1 minus V1 and U1 plus V1 and U1 minus V1 and M2 gets cancelled, sorry, V2 minus U2 by V2 minus U2, V2 plus U2. So it's this one cancelled. Right, it is remained with again U1 plus V1 is equal to 1 by V2 plus U2. Now V2 plus U2 is equal to U1 plus V1. What I can write it as V2 minus V1 is equals to U1 minus U2. This is a simple expression where it is useful to us. How this is called V2 minus V1, relative velocity of this after the collision V2 minus V1, and U1 minus U2, your relative velocity before collision. Now you can write it as equation number 3. Now if you want to substitute V2 in terms of in equation 1, you will get V1. If you substitute V1 in the equation 1, you'll get V2. We shall see that. Now from the equation 3, we will write it as V2 is equal to U1 minus U2 plus V1. Substitute above equation in equation 1. So what is equation 1? Actually M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So in place of V2 we'll substitute that M1 U1 plus M2 U2 is equal to M1 V1 plus M2 U1 minus U2 plus V1. Right, now just elaborate all. M1 U1 plus M2 U2 is equal to M1 V1 M2 U1 M2 U2 M2 V1. So we'll take common U1 one side and U2 other side. So M1 U1 minus M2 U1, M1 U1 minus M2, and M2 is equals to M2 U2 and M2 U2, right. Now this is minus m2 u2 is there already, and this minus m2 u2, and v1 taking common, m1 plus m2 v1. So m1 minus m2 u1 plus 2 m2 u2 2 m2 u2 is equals to m1 plus m2 into v1. From this I would write it as v1 is equals to m1 minus m2 by m1 plus m2 into u1 plus 2 m2 u2 by m1 plus m2. This is the final velocity of the first body after collision. Right. This you can write expression 4. Suppose if the second body is at rest before collision, means a body which is moving with initial velocity u1 which is striking at second body which is at rest, means if u2 is equals to 0, then how to write v1 initial velocity now becomes m1 minus m2 by m1 plus m2 into simply u1. This is the final velocity by substituting condition u2 is equals to now v1 from equation 3 v1, how v2 minus u1 plus u2. See that v1, if you want v1, v2 minus u1 plus u2, substitute substitute in equation 1. How do you get? Let's see what is equation 1. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now we substitute v1 wherever v1 is there. Right. m1 u1 plus m2 u2 is equal to m1 v2 minus u1 plus u2 plus m2 v2. Just elaborate. m1 u1 plus m2 u2 is equal to m1 v2 minus m1 u1 plus m1 u2 plus m2 v2. Let's say u1 one side and u2 also one side and v2 other side. So m1 u1 plus m1 u1, m2 u2 minus m1 u2 is equals to m1 plus m2 v2. So we'll write it as 2m1 u1. I am taking common u2 here, m2 minus m1 u2 is equal to m1 plus m2 into v2. What is v2 here? v2 is equals to 2m1 u1 by m1 plus m2, m2 minus m1 u2 by m1 plus m2. So this is an expression of final velocity after collision. And after collision also they travel in the same straight line, that is one dimensional collision we can call it as. If we substitute u2, which is the second body at rest, now the second body before collision at rest, but the second body will have velocity, so v2 is equal to 2m1 u1 by m1 plus m2. So this is second body velocity after collision. But this 4 and equation number 5, both are common equations of final velocities v1 and v2, and we substitute the different conditions, then we'll obtain other equations of v1 and v2. Now write the special conditions. These are the v1 final velocity after collision. This is v2 after collision. Suppose if condition 1, if m1 is equals to m2, what happens? v1 is equals to 2m2 by m1 plus m2. Then what happens? See that 2m2 u2, right? Now what happens? v1 is equals to, let's say, 2m2 by m2 plus m2, 2m2 into u2. What is this? v1 is equals to u2. Final velocity of the first body is equals to initial velocity of the second body. In the same case, if u2 is equal to 0, second body at rest, simply final velocity of the first body is equals to 0. Now what about v2? v2 is, let's say, 2 m1 u1 by m1 plus m2. Again m1 I am writing because m1 is equal to m2 plus 0. What happens? Now v2 is equals to m1, m1 gets cancelled, u1. So what is this? So second velocity, final velocity of second body is equals to initial velocity of the first body. This is as first condition. Now case 2, where the second body mass is very much heavier than the first body, then what happens? Substitute these equations again, you will get it as final velocity of first body, which is equal to initial velocity, which is negative. Seems that second body at rest, initially second body at rest, u2 is equal to 0. Let's say this u2 is equal to 0, then m1 is negligible. Then what happens? m1 can become 0 and m2 cancelled, but minus m2 is there, and minus u1 you will get it as. Second one, what is the final velocity of the body? Which is equals to 0. Final velocity of the body. How it is? This is big lorry, a small bicycle is there, so moving with velocity u1 and u2 is equal to 0. What happens? It is moving and crushing, striking this one. What happens? This cannot be moved. It can be final velocity becomes 0 again, but after collision it comes back. The final velocity of the first body after collision, which is equal to the same velocity u1 but in reverse direction. This is a simple conditions, and you can write, you can m1 is greater than m2 or u1 is equal to 0, where you can write many conditions and obtain the proper relation which are helpful to solve the problems. Now, writing the expression of coefficient of restitution and definition of that. Let's say that u1 and u2 be the initial velocities of the bodies before collision. V1 and V2 be the velocities of the two bodies after the collision, right? The coefficient of restitution is defined as it is a ratio of the relative velocity after collision of the two bodies. This is relative velocity after of the collision, which are called as separation, by relative velocity of approach u1 minus u2. What is the meaning of this? Suppose saying that m1 with u1, m2 with u2. So these are called as approaching, where they are approaching to collide. Now what happens after collision? They are getting separated. So the relative velocity after separation is v1 minus v2. Here the relative velocity of approaching or of colliding u1 minus u2. So the ratio of this v2 minus v1 by u1 minus u2, which is called as coefficient of restitution. That E value depends on nature of colliding bodies. Nature of colliding bodies. What is meant by E is equal to 0? What is meant by E is equal to 1? What is meant by 0 to 1? Lies between 0 to 1 means between 0 and 1. E is equal to 0 means the nature of collision is called as perfectly inelastic collision. E is equal to 1, perfectly elastic collision. And most probably the collisions are elastic collision. Suppose they'll have practical value that lies between 0 to 1, means 0.1 to 0.9, right? To determine the coefficient of restitution, we'll take simple example. One is spherical ball and a plate, a material like a plate we will see. So assume that this is a plate is there, plate which is placed on the ground like that. A sphere is allowed to fall on the plate. This is m2 and this is m1. So this is coming with a velocity and striking the surface of the plate with the initial velocity u1. What is the initial velocity of the plate, which is at rest? Now what is u1? If you observe that as it is freely falling with a height h1, if you choose this, u1 is equal to under root of 2gh1. Now what happens again? The spherical ball will bounce back and going to up again, like this is spherical ball raising the height h2. What is the velocity, initial velocity of u1? What is the final velocity of the first body? This is called as first body. Now the initial velocity of the first body u1, final velocity of the first body v1, which is raising the height v1. So what happened? Raising the height h2, v1 is equal to minus, you will get it, 2gh2. What is the final velocity of the material body, which is at rest only, because it cannot be moved? Just you imagine that ball bouncing the wall, what happens? Now substitute the equation here. E is equal to v2 minus v1 by u1 minus u2. So 0 v2, v1 means minus of 2gh2, u1 2gh1, and u2 0. So E is equal to rho gh2 by 2gh1. So this is ratio of the heights where a spherical ball bouncing up, that decides the coefficient of restitution. Right, next, what is that? E is a number which is dimensionless. Now consider collision in 2 dimensions. How to solve such problem? Let's say m1 with u1 velocity, m2 is moving with u2 velocity. After collision, imagine that m1 is flying off like this, m2 is flying off this. This is a natural thing where you observe in the accidents after crashing it, where they cannot move in the straight line. This is the realistic situation. Think that theta 1 is an angle making with an x-axis to the body m1 and theta. This is velocity v1, this is velocity v2. Velocity is the vector. Now x component of the momentum, x-axis, y-axis momentums can be seen separately. How this is possible? Generally we know that the linear momentum before collision and after collision are equal, m1 v1 plus m2 v2. Here v1 can be having x component as well as y component. So let's say that x-axis can be written separately, m1 u1 plus m2 u2 is equal to m1 v1 x plus m2 v2 x. You also write it as x and x, no issue. Now m1 u1 x, of course, where they are in the x direction only, m2 u2 x is equal to m1 v1 cos theta 1 plus m2 v2 cos theta 2, because this component is x component v1 cos theta 1, this component is v2 cos theta 2. Y-axis can be written as m1 u1 y, m2 u2 y is equal to m1 v1 y plus m2 v2 y. So this is 0 because body before collision it cannot be in y direction, there is no motion in the y direction. So 0 and 0. We will write it as m1 v1 sine theta 1, m2 v2 sine theta 2. This is y component. This is y component. Right? In this way, we can apply. And as well as if the elastic collision is there, if the collision is elastic, then what happens? Of m1 u1 square of m2 u2 square is equal to of m1 v1 square of m2 v2 square. We apply it here. For this case, u1 having no problem, u2 having no problem. v1 means directly we cannot write v1. v1 has some theta components. You can write like that. v1 is a vector, right? v1 cos theta 1 I plus v1 sine theta 1 j. So this is called as x component of y component. v1 is a vector is equal to v1x I v1y j. Similarly, v2 is a v2xi plus v2y j. In that way, the v2 v1 vectors can be written, and obviously we will find magnitude by using this vectors and substitute over there, and we will get it. So first understanding the situations and theta 1 theta 2, and remember theta 1 means below x axis, theta 2 can be negative, above the x axis theta 1 can be positive. In that way we'll solve the problems. In the next class the related problems can be solved. Meanwhile you learn the topics and try to solve the problems. We'll try to solve the example problems and some unsolved problems related to the topics which we learnt.